know it's true, but let's go back to flat Earth. Why do you believe in the Earth's globe? Why do you believe?
It's physically impossible for the Earth to be flat for huge numbers of reasons. Extremely simple reasons that extremely simple minds could even comprehend. Have you ever seen the moon?
Give me one reason then.
Have you ever seen the moon?
Yes.
Okay, well, we're going to do an analogy first because I love analogies because it proves how you guys literally don't know how to think. Let's imagine you and I are in a basketball court, okay? You with me so far?
Yeah, go ahead.
Okay, there's a ball hanging in the middle of the ceiling in the basketball court, okay? Are you with me so far?
Yeah.
You and I are on opposite ends of the basketball court. You with me so far?
Yeah, of course.
If we look at if we look at that ball that's hanging above the floor, are we going to see the same parts of it?
All right, I can give you. First of all, yes, we would.
No, we are not going to see the same parts of it. So this is why I said you guys literally don't know how to think, even with the easy examples.
So depending on the distance. And
no, it does not depend on the distance.
Yes, if it's always circling, facing the same direction, you're always going to see the same size or side of it.
No, you absolutely cannot.
Is the moon spinning?
Look at this picture that I drew. Oh, I gotta get rid of my background real quick. Look at this picture that I drew. Tell me how it's possible for us to see the same parts of that moon. One person can see the left side, the other person can see the right side. Do you acknowledge this now, that it's not possible to see the same side of the ball?
So if the moon, what is the moon first of all? What is the moon?
The question is, do you acknowledge that it's not possible to see the same side of the ball?
No, I mean, from this, if it's a ball and if it's physical, for example, yes, it would be impossible. But if it's a ball and if someone is on the north and seeing the same moon, of course, no one is going to see the moon from two different side of it, because it's the distance. It's pretty high. Usually, you can't see the moon from the south.
Even if I was grading you on a curve and you were a kindergartner, I still wouldn't consider what you just said to be a sentence. So can you try again?
I'm saying, do you know what the moon is? Have you ever been there?
I've never been to Australia, but I know that it's a continent.
I mean, no one has been to the moon except 5 people, 6 people.
12 people.
So you believe those 12 people?
I've seen the moon through a telescope. I can tell that it's not whatever the fuck you think it is. You can see shadows and craters on it.
Yeah, of course. If it's one-sided, it could be flat, for example. Flat.
No, it cannot be flat. Do you know why?
How do you know? Go ahead.
So, if I were standing directly underneath something that's flat and shaped like the moon, what would it look like?
Flat against, adjacent to the physical barrier.
Holy fucking shit. There is a flat circle directly above you. What does it look like?
I'm giving you adjacent to the barrier.
There is a flat circle directly above you. What does it look like?
What do you mean? I'm not saying it's flat.
See, you guys don't know how a circle works. And you're going to sit here and try to tell us what the shape of the Earth is. You don't know how a circle works.
Listen, so I'm explaining to you. If it's facing us, it's always going to look like it's circle. You've never seen the moon spinning. You've never seen the other side of the moon. How do you know it's a sphere, for example?
Because, it only looks like a circle if you're directly underneath it. Even you understand that. What starts to happen if you're somewhere else and your perspective changes? Is this a circle?
But is that what I'm claiming?
Is this a circle?
That is not what I'm claiming.
Yes, it is. Is this a circle? Is this a circle?
Where are you at?
Is this a circle?
That's not what I'm claiming, though.
Is this a circle?
That's not.
Is this a circle?
No.
Okay, you are correct. It's not a circle. So the moon is not a flat disk above us because it would not look like a circle to anybody except whoever is directly beneath it. So we can get rid of that idea, right?
No, I'm not saying if it was attached to the firmament. For example, we need physical barrier for pressure. We know this, right?
No, we don't know that.
Yes, we do not. We
No,
do.
we don't know that.
Explain a pressure without a barrier.
Planet Earth.
That's the only explanation. The only example you're claiming
No,
it
it's
is.
not the only example. Inside of fusion reaction chambers, they have spinning hydrogen gas, and an electromagnet on the bottom keeps the gas toward the bottom part of the container, while the rest is a total vacuum.
Yeah, is there a
So
barrier?
if you have forces at play, you can manipulate gas in an environment so that there are differences in the so you can have gas next to a vacuum or whatever.
But a force is never a container. A force can never contain an air.
Yes, it can. I just gave you an example.
Have you ever seen?
Oh, you're saying it's not an open container. Okay. Giant, do you acknowledge that if you go up in a hot air balloon, the air gets thinner?
Yes, I do.
What are you doing?
I do. I do acknowledge
Are you at an airport?
it. No, I'm in my school, but I'm telling you, as we go up, we know that there's less air as we go up, right?
Does the air get to the point where it's 1% the density it is at sea level?
1%. So if I was in
You can
the
just
high,
hurry up and say yes, because
I
we
mean,
know this
yeah,
for a
I'm saying
fact.
so. If we were
Does it
at
get to the point where it's 1,000 times less dense than it is at sea level?
let's measure it to Pascal. Let's use Pascal.
Does it get to the point where it's 1,000 times less dense
How
than
are we
sea level?
measuring this? How are we measuring?
Does it get
I'm
to the
asking you,
point?
how do we measure this?
Even people like you believe there are weather balloons, and we send them up to places where those are the conditions. So we
I'm
know
telling
this
you,
for a
if I was
fact,
at the
right?
highest place in Earth, like let's say mountain, the highest mountain in the world, it would be 30 something Pascal, 30,000, 38,000
That's
Pascal.
fucking great. Get a weather balloon to go up tens of thousands or 100,000 and more feet higher than that, and it begins to become 1,000 times less dense than it is at sea level. We know
Okay.
this for a fact.
And that is adjacent to a vacuum that is the best and the most
Your
strongest
your
vacuum we can ever have on Earth.
vacuums are not forces that do things. Okay,
Well, if
you
you have a
this
void,
is
but
this is
if you have a
10th
void,
grade level high school science.
no, I'm telling you, if you have a void and you have gas particles right here
If you
beside
are
it,
correct about this, then all of the air at sea level needs to be flying up to equalize the pressure.
it does
Why does it
slowly.
not do that?
It does slowly,
No,
but
it
because
does
we have,
not do that.
as you raise the air particles, the gas particles raise up. You don't know this? This
No, I
is
don't know things that aren't true.
this is actually high school level physics. But
I
I'm
know you
telling
are,
you,
but what am I? If you're going to
as
try
we
to
go up,
insult me, don't plagiarize me.
I'm telling you the truth. As we go up, the level of air goes higher as it rises up. Gas particles go up, and because we have a physical barrier at the end, we are able to have pressure, and because and due to the density gradient, temperature, we have pressure gradient. It's simple, but without that physical barrier, all the air that is adjacent to a vacuum to what is 10 to 13 air pressure,
It doesn't matter
they
if you
just
have
suck
a
it up.
vacuum. You idiot. You also can't have
I'm
a
telling you,
pressure
look,
gradient. What happens when you open a can of soda? What's the sound it
that
makes?
explains mine.
You don't have
Without
an
that,
explanation for this.
I mean,
Why does the air rush out of a can of soda?
because you don't have that physical barrier anymore. That pressure in that bottle is going up to
Why does
equalize
the air come out of the can?
to get it to find its medium on the air.
To equalize the pressure.
Of course, yeah.
The air pressure way up above us is thousands of times lower than it is at sea level. Why is the air not flying up at incredible speed? The difference in pressure in a soda can and sea level isn't that extreme, yet that air comes out of that thing immediately. There should be winds hundreds of miles an hour, literally all the time, flying upward.
That is due to first that is due to the temperature we have. We
No,
know
it's
that
not.
as you go up, we get colder, right? It gets
If it
colder.
got colder, it would get more dense. It would be
Cold
like your
particles.
skull.
Listen, cold particles have less kinetic energy, less motion in the particles. That
Is
shows that
cold air more dense than hot air?
hot air is more dense than cold air.
No, it's not. Congratulations.
I'm telling you, in terms of kinetic energy, as you
You're
go up,
telling me
you have
bullshit.
less.
Hot
You
air
have.
is less dense than cold air.
So can I share my screen so I can show you from a source? But I can't share my screen. I don't know why. How do I share my screen?
You can't share your screen.
But I'm explaining to you that the kinetic energy, the motion in the energy we have as you go up is less.
I'm aware of that. Do you know
So
that it gets
that is.
hotter as you go up once you get to a certain point?
I know that's the reason, because of that pressure that is pushing the air back to the earth. That container. Without that container, you wouldn't have.
There is no container.
I'm telling you, there is. Without that, you wouldn't have air pressure at all.
You couldn't have pressure gradients with it. Tell me why it's possible for the air to be 1,000 times thinner than it is at sea level, but it can't reach zero.
You talking about altitude, like high altitude?
It doesn't matter. As you start at sea level, the air pressure is, we'll just say 1, and then we go way up to here, it becomes 1,000 times thinner. If we go up higher, it becomes 10,000 times thinner. Why can't the pressure simply disappear altogether if it can get to tens or hundreds of thousands of times less pressure?
I just told you, because of temperature and the air
Because of
above us.
temperature.
The air above us is pushing down the air.
No, it's not.
Yes, it is.
No, it isn't.
It is. This is like, you can research this.
The
When you
air
have
at
air
the air at a weaker pressure is pushing on the air at more pressure below it. Do you know how fucking stupid that sounds?
the air above, if you
Has
have
less
air
pressure.
above,
The air above has less pressure
it's still pushing.
and is able to push on the air with more pressure because of what?
Because of what? What do you mean? The air pressure has density, right? It still has density, even though it's not
Yeah, less
more.
density.
Yeah, like, even though it's not more denser than the air at sea level, it still have density. So that density above
Do you
it
under
is
do you
still pushing.
understand that when you have two forces and one is larger than the other, it always wins? Do you understand that? Do you know what
I'm
happens when
saying
a
that
car
it
and a
is
train get into a head-on
never
collision?
one. It's
Because
never.
you're telling us that the car wins.
I'm telling you, it's never one explanation. You can have multiple explanations for it.
Yes, and your current explanation is literally, it's not just that it's
All
wrong,
right. So
it's
this
the
is how.
opposite of what's true. So, the air above us has less pressure. That means it doesn't have the pressure necessary to push the air at higher pressure below it down. That's
No,
not
listen.
possible.
Just search.
This
Simple search, right?
explanation of yours goes
No,
absolutely nowhere,
I'm gonna prove it.
completely
I'm gonna prove it.
defeats your
Give me a
own
second.
position. You need
Just
to
search.
abandon this.
No,
The same way you've
just
abandoned
search.
critical reasoning, you need to abandon this particular argument.
No, I understand what you're saying, but I'm saying just search a very quick
Then give
search.
up on it. You
Can
just
you
told me you
have just
understand it.
search? Can
Nope,
you have?
you're going to stop. You just told me that you understand. So are you going to abandon this and admit that your explanation is wrong?
I think my explanation is more logical. I mean, if maybe you don't understand it, but I'm giving you example. If you
No, you're
have
not.
just search simple question. Can you have the pressure gradient in a container? You can still have pressure gradient
No,
in
you
the
can't.
earth. You no, you
On
can't.
Earth, you can, because Earth is huge and the force of gravity
No, I'm
holds the
saying
atmosphere
it's
down.
any container.
Yes, that is true.
Any container. I'm talking about any container. If you have if you have one container and below it is hot air, and above it is cold air, you would have air gradient that goes as you go up. It gets less thinner and less thinner. Any container, simple container. I'm talking about. So you can search this. You can do
No,
this.
you can't.
Just search it
If
and
you
say
had
it.
a container and you heated the bottom, you could say that there's a difference. But do you know what? But that would only be like in a snapshot type of view. Do you know what happens over time? The pressure equalizes. So again, the air at sea level not only needs to it wouldn't be leaking upwards, it needs to be flying upward. It would do it instantaneously at hundreds of miles per hour. When you open a can, the air doesn't leak out, it rushes out at incredible speed. But those pressures aren't as extreme as the pressure we're talking about.
Well, I'm
So
telling you.
we're done with
There
this.
are
It's
many.
beyond stupid. What do you want to talk about next?
Beyond stupid, you don't know about. I think you don't
Yes, I
understand
do
it.
know about it. I
You don't
explained
understand
everything
it.
about it to you, and
So
you
I just
admitted
showed
that
you
it
that
doesn't work.
you can search online. Can you have gradient, pressure gradient, any container, any container? It will say yes. It will say yes, because the difference in temperature in the air above that container, on the top of that container, is pushing the density of that air above that on the top of the container is pushing down. It's always
Once again,
pushing
not
down
even
because it's
close
above
to
it.
being a sentence.
So it's because it's above the air below it. It's always going to push it because it has density. I don't think you don't.
The air above is not more
If you're
dense
not,
or at more pressure than the air below.
I know,
So
but it's still
again, I'm
pushing
not
down.
I'm not going to correct you for a fifth time on this.
Correct
What
me
do you
on
want
what?
to talk about
Listen,
next?
listen. Correct me on what? I have verified this information 100% through science. I don't even deny science. This is through science, through observation. You can
What do you
have.
want to talk about next?
All right. Let me ask you something. Why do you? How do you think? Do you think that we orbit and spin the Earth at the same time? We do orbit and same, right?
Yeah, obviously.
And when you, if someone in the north is spinning and orbiting the sun, and would you agree that it's every hour it's looking at a different direction? It is at a different direction, right?
Yeah,
If that's the case in the north, how do you see Polaris? If the Earth
because
is
it's above you.
yeah,
God, you're
if
so
the Earth
fucking stupid.
let me. If the Earth is tilted down and spinning, and it's the other side of the moon of the sun, how do you see Polaris at the same place?
Are you indoors or outdoors?
Me indoors. I mean outdoors. I
What's
know.
a you're outdoors right
Are you
now?
talking about like? What are you talking about? Like,
What is above you? Tell me something above you that you can see.
but I'm telling you, if you're in a different
Tell
direction,
me something that is above you that you can see.
you're trying to.
Tell me something that is above you that you can
You're
see.
trying to gaslight people, but let me explain to you. You
You
can never see.
gaslighting a stupid person is just
Listen,
when you
listen.
have a conversation with
You
them.
can never
It's
see.
unavoidable.
Oh, okay.
Tell me
I'm
something that
explaining
is
to you.
above you.
I'm explaining to you. You can never see a Polaris if you're spinning
You have so few dialogue options. Tell me something that is above you.
the sky. Why are you asking me this question?
Be more specific.
The sky, I'm outside.
Okay, we're just going to have to use our imagination. I hope you can do that. Imagine you're in your living room. Are you with me so
Is
far?
this how you do it? You just like overtalk people.
Imagine you're in a living room. Are you
No,
with
no,
me
let
so
me ask-
far?
You overtalk people and just claim you're winning. Is that
Imagine you're in a living room. Are you with me so far?
Go ahead, explain it.
Imagine you're in a living room. Are you with me so far?
Go ahead. I'm listening.
Are you with me so far?
Yeah, I'm listening. I'm with you.
Let's say that you draw an X on the ceiling directly above you. Are you with me so far?
I'm listening.
Are you with me so far?
I'm listening. Yeah. You have
Okay,
X
now
above
what you do is you turn around and face the other direction. If you look up, are you going to see the X on the ceiling?
at the same position.
Yeah.
if I'm on the Earth and I'm spinning, let's say if the
Okay,
X.
I finally understand what you're trying to say now. You're telling me that Polaris should be going like this instead of staying in a pinpoint location, right?
Polaris should be at a different,
Right?
sometimes tilted.
That's what you're saying, right?
I'm saying that Polaris should be like at a different, even small, every very small difference in the position that it is.
Do you realize
You
that
know,
Polaris is many light years away from us?
yeah, I know.
Right. So
You
if
know how,
even if even
you know
if
how
you
far it
take the
is?
distance from the Earth to the moon, the angle that would be created from Polaris to the Earth to the moon, the angle would be too small to know to notice. Do you get that?
But you're facing a different direction. I'm telling you. If you're in the north,
Okay, so now you're back to the other thing. Now,
if I was
see,
gonna
this is what
listen,
I thought you were talking about earlier.
if I
You,
was gonna
for
show
some
you,
reason, think that if you turn around, you can't see things that are above you. That's not true. Then what you did was you tried to change it to, well, if we're spinning, then it should wobble. Then I explained to you it's too many light years away for you to see the angle. Now you're back to the first thing you said.
let me explain it to you again. Do you see a
You don't need to
circle?
explain it to
Do you
me.
see a
I know
circle?
exactly what
Do you
you
see my
meant.
car? Do you see my car in a circle above it? The circle. Let's say you're above it, in the north. Let's say you're in the north. You're tilted it like, and it's tilted, and it's spinning, and it's orbiting the sun. You shouldn't be able to see the moon, the North Star, every day at the same position every single night. You shouldn't be able to see that. It's impossible because
No, it's literally not impossible.
you're facing in a different direction than you were. When you face it at a different direction than you were, that North Star.
It's above you. Do you
I
know
know
that
it's
do you know
above you.
that what's above you is above you whether or not you're looking left or right? Do you know that?
I'm telling you, is the
The
Earth
question
tilted?
is, do you know that things that are above you are still above you whether you look left or right?
What? I'm just telling you, we
You
are
don't know
tilted.
that.
We
Okay, the
all
things that
listen.
are above you whether or not you look left or right. They are still
It's not
above
about
you.
looking
Now
left
that
or
you
right.
now you know it. Congratulations.
It's not about looking left or right. If I move 1,000 miles in 1 hour and 67,000 miles, circling the sun every night, I shouldn't be able to see the sun.
Now I get you. Yep. So you should buy my book because I answer all these questions in the book. So I can get you the actual numbers on this. Are you ready?
The book. So
Huh?
you have like lists of flat Earth questions, and then you just answer them.
Yes. It's called Rational Answers to Stupid Questions. And I wrote this book because I've talked to hundreds of people like you. So,
Oh wait. So you talked hundreds of. So you're just denying the evidence.
no, I've looked into so here, I can prove that your argument here is completely stupid. If the earth is moving, then the stars should change, right? I wrote about this already. I thought way ahead of you. Why don't the stars change if earth is moving so fast? Here's why. You've probably noticed that when you're driving in a car, the telephone poles look like they're moving quickly, but the trees on the horizon look motionless. Are you with me so far?
Yes. So
This is
wait,
because the parallax
how
angle
much?
you
How
create
much
by
does this
moving
book?
with,
How much does this book cost?
you can get it for $10. This is because the parallax angle you create by moving with something close is very large, but for something far away is very small. The closest star to us, besides the Sun, is Proxima Centauri at around 4.25 light years. If we take the distance Earth moves in 1 minute, that will serve as the base of our triangle. The distance to Proxima Centauri is the height of our triangle. This angle, or the angle created by this, is 0.0000000171188 degrees. Can you see an angle that is
Zero
that
point
small?
zero zero. Relative to what? To me? It's
To
not even.
anything. Can you see an angle that
Is it
is that
relative to
small?
the Earth or like?
It doesn't
Like,
matter. The angles
yes,
aren't
that
relative to
matters.
anything. Can you discern an angle that is that big?
I think you're
So the
misunderstanding.
question is, can you discern an angle that is that large?
What is relative? Is it relative as
It's not
small as me?
relative to anything. Angles aren't relative to anything. Can you discern an angle that is that small?
If
The
you
answer is no, so I'm going to move
you
on.
you have your look. You are misunderstanding everything.
No,
You
I'm
need
not
you
misunderstanding
if
anything at
even
all.
in
You
class.
said that the stars need to be shifting position because the Earth is moving. The logic
How
of that is
wait, how
okay,
much
except
is
that you don't understand how far away the stars are. I
how
just
many
gave you the
miles is the
number.
Earth?
The
I'm
angle
asking
is
you,
zero point
how
zero
many miles
zero
is the
zero
Earth?
zero 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 17188 degrees. Humans can't see angles that are that small. Not even a hawk can see an
Is it
angle
compared
that
to
is
the
that small.
listen, is it compared to a human being as well as a human being
It's
or is the
not
Earth?
compared to anything. It's a fucking angle. The Earth goes from here to here. That creates the base of the triangle. The star is up there. The
Compared
angle
to
it
the
creates is
relative to the Earth?
0.0000000017188 degrees. We
But is
can't
the
see
Earth
angles that are
listen,
that
listen,
small.
listen, is the Earth looking at it or me?
It doesn't matter.
It doesn't matter. Is it
No.
is am I as big as the Earth?
If you were paying
How big
attention,
are
then you
my
would have
eyes? Wait,
heard
listen, I understand,
that
but how big are
no,
my
you
eyes?
don't understand
It's
because I
relative
said
to the Earth, not to me.
you don't understand because I said the base is the distance Earth moves in 1 minute. So you can say it's you or the Earth. It doesn't matter.
If I'm looking at it, if I'm as big as the Earth, let's say I'm as big as the Earth, and I'm looking at an angle, and someone as big as small as a human being looking at the same angle, but they see this a different angle. I think this is like
Once again, I wouldn't even charitably call that a sentence, what you just said there.
you're comparing the Earth size to a human. You have to make it relative
It
to a
doesn't
human being.
matter because what I'm doing is I'm taking the distance Earth moves in 1 minute, which is based on the speed that the Earth is going through the is it Milky Way? Yeah, through the Milky Way galaxy. So it doesn't matter because the speeds are so incredible that it doesn't matter if we're talking about something the size of Earth or the size of a human. If you don't get it, then you don't get it. Well,
Right.
why did I say if? You
I'm gonna.
don't get it.
I guess we're gonna pass it. We're gonna pass it. If
No,
you
there is
don't
no
think,
pass.
if
You
you
are
don't think,
wrong. The angle
who's
it creates is 0.00000001718 degrees. Humans can't see angles that are that small.
I'm saying
In
you're
fact,
claiming an
if we
angle.
allow the Earth to travel for an entire year, then it still only makes an angle of 0.009 degrees. Still too small to see.
All
But
right,
that's
I'm
also
gonna
not how
say,
it works because
so I'm
all
gonna
the
say,
stars in the Milky Way are rotating together so that North Star is traveling with us as we orbit through our galaxy.
no, I'm saying is that you don't understand relativity. You have to to
Yes, I
make
do.
if you're thinking a human size, an eye size as big as the Earth, looking at an angle that small, maybe you wouldn't see it. But if it's a human being with the small eyes it uses, it definitely would see that angle. So let's move on.
No, you
Let's
can't
move on.
see angles that are that
Okay.
small. I don't know how you don't get it, but you don't get it.
You're using
Humans
the Earth
can't
size.
see
I
angles
understand,
that
but
are
you
that small. There's
if a
no such thing
human
as relative to X, Y, or Z.
no no
You
if a
can't
human's eye
see angles that small.
I understand, but if humans' eye are as big as the Earth, maybe
There's
they
no
wouldn't
such
see
thing
it.
as how big or how small your eye is. You can't see angles that are that small.
All right. I think the basic,
Great.
fundamental essence. Who calculated this? You just copying and pasting this? Did you
I
calculate it yourself?
Yes, I did the calculations myself. They're not hard to do. Fucking
So
triangle. You
I understand,
you
but
look up the base and the height, and then you
I
just figure out
understand.
the
But
angle.
when you use the size of the Earth, did you use relative to a human
I
size?
don't use the
Or
size of the Earth because that's not how you do it. And again, there's no such thing as relative to anything. An angle that's too small to see is too small to see.
All right. So let's change topic. I guess you can. All right. Let's change topic. Let me ask you one question that no one can answer. Right? No one can answer. What is gravity to you? What is gravity?
Gravity is the observed It's the observed phenomenon of mass attracting mass, and it's a consequence of massive objects warping space-time.
So it's an observation. How do you know it's gravity? It's just an
Because there are
observation.
mathematical calculations that are precise to multiple decimal places that have been repeated too many times to be able to count.
Right, but
And not a
the
single alternative explanation has ever yielded any results that work.
well,
Ever.
for you to use any calculation, you need to find the rate of acceleration, right? The rate of
Yep.
acceleration.
On average, 9.8 meters per second squared.
You need to have that before you use any for any formulas or any calculation. You need that, right? You agree that you need that 9.8 meter per second square to
No, you can
calculate.
derive the acceleration if you know the mass of the object. We've done that before. We knew what the acceleration of gravity on Mars was going to be before we got there. We knew what it was going to be on the moon before we got
Let
there.
me ask you, what is the formula to get that?
To derive 9.8 meters per second squared.
So it's G M1 M2 over R2. That's what you use to get the 9.8 meter per second square.
Yeah, but if you don't know 9.8 meters per second squared, you can derive it from the other known things.
No, that is the fundamental formula to use.
Formulas can be rearranged to solve for different variables within them.
No, I understand, but let me
Okay,
go back.
so you don't need to know 9.8. You can derive it from the other pieces of information if you have them.
I'm using the average. What are you asking? I'm telling you.
I'm not asking you anything. I'm telling you that you don't need to know F. You can solve for, or you can, well, actually, in this case, you are solving for F, whatever.
That's what we're doing.
We can
That's
derive the
what
acceleration if we don't know it on a world we've never even been to, like the moon.
So no, we don't know that. We've never been. I've never measured it. You've never measured it. You just. So let's not talk about the moon. Let's talk about the Earth. The 9.8 meter per second square. You need that to calculate, to do any calculation. You need that 9.8
Yes.
meter per second
And the
square.
experiments we do with
So,
this always yield consistent results. That's how we know we have a working
right. So
model.
listen. So do you know Coulomb's law? The formula
Yes.
for Coulomb's law.
Yeah. What's the charge of the Earth?
No, the Coulomb's law. Do you know what it is? The formula.
Yes, I know. And the structure of the formula is a lot like, it's almost the same as gravity, but the Earth doesn't have a charge.
All right, so let's go back. It's very similar. You don't understand.
He asked the most basic and fundamental question, which is, what's the charge of the Earth? That's how, now I have to change the subject.
So no, listen. You don't understand the basic formula to get gravity.
Screaming. The Earth doesn't have a charge, so the idea that just because these formulas are structured kind of the same
what did you
way,
say?
they only
The
work
Earth doesn't have a
with
charge?
potential differences. Yes, the Earth does not have a charge.
Does the surface of the Earth have a charge?
No,
No.
no,
No. Oh my God! You don't know anything.
no.
Listen. You don't know anything. I'm just giving
I
you
know
the.
more than nothing, which means I know more than you.
I'm giving you. You
So,
just
do you acknowledge that the
No,
Earth is a
listen,
sphere
listen.
because in order for your equation to work, you have to have a radius?
I'm giving you the. So you don't know the charges of the Earth.
What's the radius of
You don't
the
know
Earth?
the formula of gravity.
There
You
is
don't
no
know the
charge for the
formula of-
Earth. What you don't realize
It's
is that you're
neutral. The Earth-
conceding that the
listen,
Earth is a
The
globe.
Earth is neutral.
What's the
surface of
radius of the Earth?
the surface of the Earth?
Hey,
is
Giant, what's the radius of the
That has
Earth,
nothing to
which
do
is a
with-
requirement for your formula? What's the radius of Earth?
It's 3,000 something.
So you acknowledge that Earth is a sphere.
What do you mean? I'm
You
giving
need a radius.
I'm using the information they gave us.
What does R squared mean, Giant?
to disprove that's the
Giant, what does R squared mean?
R squared is the the volume. It is. I've used it to. It's
R squared is the volume.
No, it's not the volume. It's the.
You're arguing for square circles at this point.
So no, are you just gonna say, oh, because you know the radius of the Earth, it's it's a sphere. That's not
Yep.
what I'm saying. That's not what I'm
Yes,
saying.
it is what you're saying. Well, then you need to abandon this because it can't explain anything.
You don't
Because
know
you
that.
don't have a flat Earth doesn't
Even
have
without
R
knowing
squared,
that.
so you have nothing to work with. So
not-
this explanation doesn't actually explain anything in your worldview.
Bro doesn't know what radius is.
Yes, I
It's
do.
not radius. It's not radius. So I'm.
Yes,
I'm,
it is. R squared is radius squared.
Oh my god, you don't understand.
Oh my God, you don't understand. No, R squared is radius squared.
Look.
Giant, what's R squared?
I'm giving you. It's not just.
Giant, what is
radius
R squared?
It's not radius squared. It's not.
Yes, it is.
To find gravity, you need radius. The radius of the Earth. Is that what you asked me?
To use this electrostatic
what-
formula, you have to have a radius.
So I'm telling you.
Distance between
gravity.
two charged objects.
wait,
You have to have a
wait.
radius.
You know gravitational formula. The formula I told you. It's there. There is R square. Are you telling me you need the radius of the
Yeah.
Earth
To
find
do
gravity?
electrostatics, you need
find
R
gravity?
squared. It's
find
this.
gravity?
It's the same formula, just different
He's
constants.
deflecting. He's deflecting. You don't. So
No, I'm not.
let's
You
go
need
back-
R
let's go
squared
back-
for both of them.
So let's go back to the. It's not radius. The radius.
Yes,
of
it
the
is.
Earth.
It's
That's
R
not-
squared. Radius.
All right.
Yes, it is. Do you know that things weigh less the higher up you go?
No, so you claim
Giant,
it's radius.
I have a question for you. Do you
don't know
do you
it.
know
You just
that things
repeat
weigh
it,
less
right?
the higher up you go?
So are you claiming it's?
Giant, do you know that things weigh less the higher up you go?
You're changing topic now.
Giant, do you know that things weigh less the higher up you go?
Yes.
Okay, that's because the distance R squared is growing. So, yes, to do gravity, you do have to have a radius. That is how it works.
No,
So
is
once
it
again,
R
you're
squared-
wrong.
Is R squared the radius?
Yes. And why do things weigh less on the tops of very tall buildings? Because R squared grows.
Are you talking about the radius of what?
The radius is the distance you are from the center of the object's mass.
Bro, I need my computer to show you and open my camera and everything to show you that you don't. I guess it's not. There's no point on showing you, right? Let me explain to you. You need the
It
9.8.
wouldn't do you any good.
Yeah,
Oh, yeah, we're back
do
to
you want me show you?
9.8. Yeah, sure, you need 9.8 because that is the
do you
observed
want me to show you?
fact of
No,
the
listen,
rate
listen.
at which
You
objects
want-
fall
you
on
want me to show you
Earth
that?
on average.
You want me to show you?
Yeah, we need 9.8. Therefore, what? What's your argument?
That it's not. It's not radius.
Yes, it is
the
radius.
You understand it is.
Then what is it?
It's not. It's the. It has to do with the volume. I've done the calculation myself, but
It has to
let's
do
go
with
back to-
Valium? What?
The distance. Let me show you. So that has nothing to do. The point is that you need the 9.8 meter per second to do any kind of calculation that has to do with gravity. And that 9.8 meter per second square is it's just an observation. It's the average downfall acceleration of an object
Yeah, so what?
at full.
How's that a problem for anything?
So they understand that? So you're claiming that this observation, and you're tying this observation to something, which is the general relativity of the gravity that Einstein come up with, the curving space of time. You understand that? The warping space of time.
What about it?
They tied it to that. The 9.8 meter per second square is the law, and they tied it to the theory that I'm denying. I'm not denying the 9.8 meter per second square. I'm denying the theory that is tied to it.
Great.
So
Have
the
you done the
theory has
math and
no.
revealed that the mathematics
Yes.
does not yield consistent,
Well,
accurate, reliable,
no,
repeatable
because
results?
there's no math you need to do because
No, there's
90
only
ninety-five
math that
percent
you
of
need
it.
to do because this is physics.
No, I'm
The
telling you.
only
I'm,
thing,
I'm
it's remarkable that you said that because actually the only thing that would be
because
appropriate to
they
do
they
would
don't
be
know what it
math.
is. They don't know what it is. 95% of it is dark matter, dark
That's
energy. How
completely
are you gonna do
irrelevant.
math?
That's the
How are you gonna
composition
do
of the
math?
universe.
Listen, so how are you gonna do math of something you don't know its existence? You don't even know it exists.
I don't need
Do you
to
understand
know.
that dark matter and dark energy, they don't even know it exists.
Do I
They
need
just
to know
claim
what
there's something there.
Pepto-Bismol is in order to study snowflakes?
I'm telling you,
Do I
dark
need to
matter and
know
dark
what
energy,
Pepto-Bismol is in
that
order
has
to
nothing
study
to do with
snowflakes?
gravity. Listen,
Quit
that has nothing
interrupting
to
me
do with
while I'm
gravity.
gaslighting you. Do you need to know what Pepto-Bismol is in order to study snowflakes?
Do you know that gravity?
The
I'm talking
question
about
is, do you
gravity.
need to know what Pepto-Bismol is in order to study snowflakes?
What?
Do you need to know what Pepto-Bismol is in order to study
I'm not. I'm
snowflakes?
not. I'm not answering that question.
Great, so I'll answer it for you. The answer is no. So if I don't know what dark energy is, what does that have to do with gravity? Literally nothing. So there we go.
Dark matter and dark energy is 95% of gravity.
No, it isn't.
No, it
Dark
isn't.
matter, dark
And
energy isn't. Dark matter
it
exerts a
explains
gravitational
95.
influence, but it's not the source of gravity here on Earth.
Dark matter and dark energy explains 95% of what they claim is gravity, and they
No.
don't know. Go ahead and research this.
I
So
have
you don't.
researched it. Dark
You
energy
don't.
has nothing to do with gravity.
Really? That's a
Willie.
strong claim.
Yeah.
Is that a strong claim? Are you gonna
I'm
stick to
really
that?
starting to think dark energy doesn't
Are
have
you?
much to do with gravity.
Let me show you. So
Oh,
you're
really?
not open-minded then. You're not open-minded then. You're
Yes, I
just like
am.
you're just like a clown that just comes in here and just argues against
I'm
someone.
funny like a clown,
Yeah, It's not.
but
It's not
I'm
funny.
smart
No,
like
no, it's not
not a
funny
clown.
when someone is talking facts and you're just denying it, acting like a clown. That's just it.
I literally proved to you that
You
you
see,
don't even believe what you say you believe
what do
on
you mean?
multiple different occasions.
No, you crafted, you manufactured an explanation
No,
and
I'm
gave,
being
and
serious
you
right
believe,
now.
and you believe.
I
Listen.
proved to you that you can't see an angle as small as the angle for when the sun or when the Earth flies through space. There, I got it out at the end. And then you said relative to what?
No. So quit being clown. Let's just talk facts. Would you agree that?
Okay, you're an
Let's talk
idiot.
facts. Let's talk facts. When you have something and 95% of it is invisible and you don't know what it is and you don't know how it works or you don't know how it looks, would you claim it is there? Because that's what they use to explain the theory of gravity, and the only 5% they know for a fact it exists is because we
Giant,
observe we observe 9.8 meter per
giant.
second square.
Do atoms exist?
Do atoms? I've never researched. I don't have any criticism against it.
So you have no
I
problem
know, I
with.
know, I know, I know. People have like with electrons and stuff, but I don't want to talk about it. I've never done any research upon it. But let's go. Let's go back to gravity. What is gravity now? Now that I
So
have
what I was
explained.
going, I'm gonna interrupt you. So what I was going to say is, we've known about the existence of atoms. We've had extremely good scientific experimental evidence verifying our theories, our hypotheses about the nature and composition of atoms and matter since the early 1800s. We've had it for that long. But that whole time, we didn't know that protons, neutrons, and electrons exist. So does that mean that we didn't know what we were talking about in the 1800s? There was some stuff that they were wrong about, but they were largely right about everything. So not knowing what dark energy is has fuck all to do with if we have an accurate model about gravity, its effects, and how it works here on Earth.
Wait, so you don't have anything except the 9.8 meter per second square? You have
we
not.
have countless experiments to verify our model. Like, I can't use like going to other planets because you believe we never went there or whatever. But so I guess I'm not 100% sure what to use for you. But again, your weight changes if you go to the very top of a tall building because r squared changes. That's consistent with our theory of gravity.
Yeah, if
GPS satellites, the clocks in them have to tick at a different rate because they're farther away from Earth's gravity well than things here at the surface. So the
so let,
clocks are
let me
programmed differently.
let me explain to you. There is an acceleration of force. There's an acceleration of force that goes down at a rate of 9.8 meter per second square, right? And that
Yeah.
fluctuates. Sometimes it changes. Sometimes you weight something because of that force.
Yeah, because mass is not
There's
evenly
rules.
distributed throughout the
That
planet.
is that is the law of gravity. That is the law. I'm not denying that. No one's denying that. That is provable. We've proven it. We use it to build stuff up. We use it, right? But you claiming that G in itself, that G, you're tying it to galaxy and black holes, and which is 95% of it is dark matter. It has no observation. You can't observe it. You've never observed a planet getting pulled by another planet with
That is
gravity.
not a problem for anything we know about the effects of gravity here on Earth in all the different kinds of ways it's been
So
experimentally verified.
if I can prove that 9.8 meter per second square is caused by another force that we
You
know
can't.
exists, that we know it exists, and that
You
we can
can't
manipulate.
derive 9.8
This is
meters per second squared from
that,
electrostatics. You
I'm
can't
telling
do
you,
it.
in that we can manipulate. We can use it to manipulate stuff up. We can lift stuff up. We can move it around. If I can prove you
What's the
right now,
charge of the Earth?
so look, if I can
Okay,
prove you right
first of all,
now,
you have to
well,
concede
no,
that
no,
Earth has a radius, which means you have to concede that it's a globe. So are you ready to do that?
no, let's not talk about that. I'm just telling you that
No,
the
because
only
you
thing about
no,
gravity.
no, we are talking about that because
Yeah,
your
we can talk about
alternative
it, but we need
explanation
to
is
talk about it. We can talk about
electrostatics.
it.
You need r squared for
No,
your
I haven't even
electrostatics.
said
So
it.
are you going to
I
concede that
will.
the Earth is a globe?
Before I explain that, let me explain the reason. The only thing that you have right now is the 9.8 meter per second square. And if I can prove that another force is causing that force, that rate of acceleration, you now has to change the entire the 95% of gravity you don't know, you've never seen, you've never observed. That is there's a reason you don't know what it is, you don't know. But if I can prove you that it's electromagnetism, electrostatics, now everything changed. Now you can't call it gravity. And
Good luck.
The Earth is not. It's not. It doesn't. It has charge. It's neutral. It's basically polarized. It's balanced. It does have charges, but it's balanced. It's neutral. And the surface of the Earth.
Congratulations. That would mean that it has no ability to
No, no, no,
attract
no.
anything.
The Earth, the physical Earth, and the surface of the Earth is different. The surface of the Earth is negative. Provable. We use it to measure stuff. We've used it. This is provable stuff. You can go ahead and research it, right? The surface of the Earth is negative, and the sky is positive. We all know this. And there is a flow of electricity, electric current, they call it, circuit, the electric circuit that flows from positive to negative at a rate, some kind of rate, I don't know the rate, and that causes positive and positive rejects each other, and negative and positive attracts. And that is provably what's causing us to stay on the earth. That's the force.
No, it's not provable.
It is provable.
Am I on the Earth?
So, okay. So let me
So
test.
the question was, am I on the Earth?
If I'm going to
So I have a
explain,
question for you. Am I on the Earth?
yes, you are.
Okay, am I positively charged?
You're neutral. You don't have any charge on the earth.
I don't have any charge. So that's why I'm
That's
down.
why there is no other force. And you
Great.
have
So the Earth is what's the ground is positively charged.
the ground is neutral.
The ground is neutral. So if I have two things, so electrostatics, you have charge 1 and charge 2. The only way that they can produce of force on each other is if they have differences in electric potential.
Right,
Do you
right.
understand that?
I think you understand. You have the
Yes, I
foundation.
know that I understand this
No,
because
no, no.
I
You
have
have.
done this for a living.
Okay, but
Okay?
let me. If you have
No,
done
you're
it,
not going to do anything except answer some questions. Two objects that are neutral do not have a difference in electric potential. That means that they cannot induce movement in each other. Do you understand?
a neutral object always stands still.
Two neutral objects that do not have any difference
Who
in
says?
charge
Wait, wait, wait,
have
wait. But I understand.
zero
Who says?
potential. Shut up. They have zero potential difference. Therefore, they cannot induce movement in each
No, no,
other.
no. You don't understand. Who says the Earth is attracting us? Who says that? No one
You.
said it. I said the Earth is neutral and you're neutral
Which
on the
means
surface.
if I
On the,
jump
on
off of
the,
a building, there is nothing to account for why
no,
I fall down in
I
your
will
model.
explain. I will explain that the surface of the Earth is negative, as we know. The ground is neutral. As you go up, there is positive. When you are at a high altitude, you are at a positive
Then
level.
why does a helium balloon float?
Because what do you mean?
Why does a helium balloon float?
Because it is less denser and it finds its equilibrium.
No, your explanation is that the air is positive. When it's in the air, it needs to be pushed down. Why does it not push down?
I'm explaining to you, it's less denser for it to go.
That doesn't matter because there's a positive force in the air
You
pushing
think?
it
Wait,
down.
wait, wait. So you think I mean, you think density has nothing to do on how fast we go or how fast?
I think you are making shit up as you go along. You have zero explanation. You've had to forfeit everything.
No,
You have to
this is no.
use
Listen,
a
listen.
model that assumes a radius and then say that there's no such thing as the radius. You have to say that
Wait,
objects
wait,
that
wait.
are
So you can only
neutral
have radius on
move
a.
because of
Oh,
different charges around them that are pushing on them that don't push on other things.
yeah. So can you telling me you can only have radius on a sphere?
Yes.
You can't have it on a circle?
So you understand that the
Wait, can
way
you
the
have it on a
difference
circle
in
or not?
potential energy. Yeah, this isn't the gotcha that you think it is
But
because
no,
you're
no,
a fucking idiot.
you're claiming the Earth has no radius. It still has radius if the Earth is a circle.
Yes, except
So
the
what is the
problem with your
point?
explanation is that the force of attraction in a sphere, that force of attraction is toward the middle, so you're always equidistant. Now, Earth isn't perfectly spherical, but whatever. That's the that is where that radius is drawn from. In your model, a flat Earth has a radius? Sure, it's at the North Pole. That means that people at the equator experience less of an attractive force than people in the Arctic Circle, for example.
No, who
Except
claims
here's where your model
who
completely
claims the
falls
only
apart again.
attraction?
Do things get pushed toward the North
No,
Pole?
no. Who says things?
Giant, do things get
Who,
pushed toward the North Pole?
who said that?
Giant,
Did
do
I make that
things
claim?
get pushed toward the North Pole?
Only no one said it.
Giant, do things get pushed toward the North Pole?
No.
No. So then what is the point of you saying, well, if Earth is flat, it still has a radius, when the radius is part of the equation that tells you how strong that force of attraction is? So what was the point of that?
The radius helps you. It's a way to calculate for you don't know the Coulomb. You know the Coulomb's law? You don't know the Coulomb's formula, right?
See, if I'm at the North Pole or I'm at the equator, if Earth is a globe, then we're still being pulled toward the center
No,
of the
you know
Earth.
the
If
Coulomb's.
Earth is flat, then that radius is there in the middle, and now everything is completely fucked up, and there's
You know
no
the Coulomb's
there's
law.
no equidistant points unless you're on the same
No,
line of
the
latitude.
Coulomb's law.
This explains nothing at all.
I'm saying the Coulomb's law uses
You need a
radius.
radius. Yeah, so
The,
what's
that
your
Coulomb's
radius
law,
here?
that Coulomb's law is a way to. What do you mean? Why?
Yeah,
Why
what
do
is your radius?
it does?
What is your radius?
It's not the same radius you're thinking of. It's
Then
not the
what
same.
is it?
I will explain to you right now. That's why I said at first it's not
You
the
have
same radius.
15 seconds. What is your radius?
I'm gonna have to show you some.
You have 5 seconds.
You don't want. You
You
don't want
ran
me
out of
to.
time. You don't know what the
You
radius
don't
is.
want.
You're going to
I'm
pull
just
up
showing
some
you this.
fucking
I can't explain it to you.
bathroom stall style drawing to be like, yeah, this guy who's a crackhead, he figured
I'm
this all
showing you.
out.
I'm showing you right now. Give me 1 second.
Tell me. If you know it, then you can just tell me.
It's not the same radius you were thinking of. It's the so now what it is. I want to give you the right. It's the distance, the straight line distance between the object at the end and the object in the to the middle. It's not the distance
Great. You know what has a
within the
middle?
ground.
A sphere has a middle.
A circle even also has a middle. A circle, a center.
Fucking Christ, you're so goddamn fucking
But
stupid. It's almost unbelievable, right? So the electrostatics, those
wait.
two objects are pulling toward that radius, right? So are
Who
things
said?
moving toward the North
Who said?
Pole?
Who said? Who said?
Are things moving toward the North Pole?
I said no. Who said?
So then why are you bringing up that a flat Earth has a radius?
It could be the attraction to the Earth's surface. You still need the radius.
If we're being attracted toward the Earth,
Toward look. So
buddy, oh no, I'm not, nope, I can't. I literally can't.